Very exciting. Tonight we are going to set up and actually solve the trig ratio problems. Okay, so take out this page in your notes and start your engines. All right, the steps. First, we're going to draw a picture always, if necessary. Then we're going to determine which trig ratio to use, which we did yesterday. We will set up an equation, which we did yesterday. Okay, and then we'll use the sine, cosine, tangent buttons on our calculator to multiply or divide to get x. So if you want to look at your calculators, the sine, cosine, and tangent buttons are here. Okay, those are where your sine, cosine, tangent buttons are on your calculator. Then we will always round to the appropriate or designated place value. It seems like a little thing, but it's a big thing, trust me. All right, so let's get started. Now, you should be able to identify at least which trig ratio you should be using here. Okay, so what I would like you to do actually is pause here and go through these 8 problems. Actually, these are the same 8 problems that we had from yesterday, aren't they? I forgot about that. So that's good. We already have that settled. So you should have, if you have your notes from yesterday, you would have that. If not, you could always check yourself and make sure you're getting it right. So let's go back and take a look at this. This one was sine of 40 equals x over 25. Now, this is the best way to do this is actually to isolate x first. So in order to get x by itself, what I would like to do here is multiply both sides by 25. Okay? Because that will cancel out the 25s here, and I'll just be left with x. And x is going to be 25 times the sine of 40. Now, how do you do that on your calculator? All right, very important here. Take out your calculators. What I want you to do is I want you to do 25 times sine of 40, and then I want you to do sine of 40 times 25. You should have gotten 2 very different answers. One of them probably doesn't look like it's right, and it doesn't look like it's right because it's not right. This one here, which was this calculation, is not correct. And the reason is, if you think about it, the calculator is taking the sine of 40 times 25. Okay, so the calculator is taking the sine of 1,000. Not making sense, right? So that's why you get this negative number. If you're ever doing a trig problem and you get a negative, there's two possibilities. One is you punched it in wrong, and second is your calculator is in radians, which you'd have to ask me. I'd have to change the mode there. We want it to be in degrees, and it should say that kind of at the bottom. It should say DEG versus RAD. If it says RAD, then we have to change that. Okay? You don't want it in radians. Okay, now this should sound a little confusing, all that stuff, because it is confusing. There's a whole course in trigonometry when you take Algebra 2. So, you're not supposed to understand all of this, and that's okay. Some of it should be a little confusing, but the basics we should be able to get down. So the answer here is actually x is approximately 16.1. That's that 16 units, whatever that was. That was the 16.9 or 09, blah, blah, blah. All right, the second one we had sine of 50 equals x over 15. And again, you're going to want to get the x by itself. So I'm going to multiply both sides by 15. And when you plug that into your calculator, 15 times sine of 50, you should get approximately, that's why I use these little squiggly equals, 11.5. And that's whatever units we had there. In these cases, you don't have units, but it's always best to get in the habit of putting something down. Okay, we have a tangent problem here. How exciting. I get to use a different button. So tangent of 30 equals, this is opposite over adjacent, so x over 14. So I'm going to multiply 14 by both sides to cancel that. And if you do 14 times tangent of 30, you should get, drum roll please, x is approximately 8.1 units. Not too bad, right? Hardest part's figuring out what you need to do. Okay. I'm going to extend this page here and bring you up. Okay, the next one, tangent of 20. Actually, I'm going to skip that one for now. Let's go to the next one. Get a little more practice before we tackle that. Okay, somehow I got a squiggle there. All right, sine of 36 equals x over 17. I want to clear out the 17, so I'm going to multiply both sides by 17, and I would get x is approximately 10. Good? If that had asked you to round to the 10th, we didn't have any rounding here, but you would have put 10.0, just so you know. Okay, we always leave a digit where they ask us to round to. The next one, cosine of 50 equals x over 10. So you multiply both sides by 10. 10 times cosine of 50 equals x, and x is approximately 6.4. All righty, I think we're ready to go back and tackle 4 now if you're doing okay. This one's a little different. Tangent of 20 equals 22 over x. Well, in this case, it's going to be a little harder to isolate x. First thing I want to do is multiply both sides by x, okay? And then they cancel. So I get x times tangent of 20 equals 22. But I want x all by itself. So tangent is actually a number. If you plug in tangent of 20 in your calculator, you're going to get a number. You're going to get, let's see, tangent of 20 equals 0.363970234. So this is a number. I'm going to divide both sides by tangent of 20 to get rid of it. And I'm going to divide this by tangent of 20. Okay, now I'm going to go down here, we'll run over here. X equals 22 divided by tangent of 20. So you want to go over to your calculator and you want to put in 22 divided by tangent of 20. And then you hit equals. Okay, so 22 divided by tangent of 20 equals, and that should be 60.44450, blah, blah, blah. Okay? So these are a little different because they're a division instead of multiplication. You have to be careful with those. So this one, I'll write it in red here, is 60.4 approximately units. And I forgot my little units here and here. All right. Let's look at 7. 7 was sine of 25 equals 5 over x. So I'm going to do the same thing, multiply both sides by x. So x times sine of 25 equals 5. And then I have to divide both sides by sine of 25. Remember, this is just a number, so it cancels. And I have to actually do the math on the other side. 5 divided by sine of 25 should be approximately 11.8 units. And then there would be nothing to do on the last one. I'm going to do a couple word problems with you next to show you how to use a picture. The pictures are the hardest part, guys. Okay? They really are. A wooden beam, 8 meters long, leans against the wall. So this is like our old ladder problems. Okay, here's my right angle. Makes it an angle of 71 degrees with the ground. Find to the nearest tenth of a meter how high up. Okay, so which trig ratio would I use? You have to look at the angle. What is this segment? What is this segment? This is H. And in relation to the 71, this is O. So this is going to be an OH or sine problem. Sine of 71 equals x over 8. So you're going to multiply both sides by 8. And 8 times sine of 71 is approximately 7.6 meters. Now you see why I wanted you to use units. Archie, who is flying a kite, lets out 300 feet of string. So not only are these popular with Pythagorean theorem, they are also popular with trig problems. Okay, here is my kite. Here is the 300 feet of string. It makes an angle of 52 degrees with the ground. Assuming the string is stretch taut, find to the nearest foot how high the kite is. So in relation to this angle, what is this and what is this? They are H and O again. So this is going to again be a sine problem. Sine of 52 equals x over 300. Multiply both sides by 300, and x is 300 times the sine of 52, which is approximately 236 feet. This brings me to another point. If you got like 4 feet there, probably not right, okay, for 300 feet of string. Does your answer make sense? Always ask that question. Nick is flying a kite. The kite string makes an angle of 43 degrees with the ground. I'm not sure what you guys have there, but anyway, it's the same person. So if it's Nick, Nick. If it's Nicholas, Andre, it's supposed to be Nicholas, Nicholas. Not sure what that's supposed to be there, but okay. So we've got this basic kite problem again, all right? If he's standing 100 feet from a point on the ground directly below the kite, so he's standing 100 feet from a point on the ground. 100 feet goes here. This is the point directly below the kite, and I want to know the length of kite string, and it makes an angle of 43 degrees. That's what the picture should look like. A lot of times the picture is the hardest part, okay? So if we write this out, we will get, we're looking at this angle, and we want to talk about this side and this side. The x would be my hypotenuse, and the 100 would be my adjacent. So if I set that up, it is going to use cosine. Cosine of 43 equals adjacent 100 over hypotenuse x. Now this is one of those harder ones, so you have to multiply both sides by x. Okay, and then you're going to divide, so that would be x times cosine of 43 equals 100. Now I'm going to divide both sides by cosine of 43. And x is going to be 100 divided by cosine of 43, which on your calculator should be approximately 136.7, but it says to the nearest foot, so that's approximately 137 feet. Final answer. Okay, always go back and check that. And that would make sense that the kite string is longer than is the distance he is away from that point on the ground. Again, does your answer make sense? All right, we're going to practice more of these word problems tomorrow, and I hope you guys have a wonderful evening. Ciao.